Hello there. Well, I'm not going to repeat the title because it's really large. So I'm just going to go straight for it. So redirected walking, right? Redirected walking basically modifies the path of a user without them noticing. And we use this to overcome the space constraint on VR. And one great example of this is translational gain, or TG, which basically applies a gain when you're walking. For example, if you walk 1 meter on real life, and you apply a gain of 2 on the virtual world, you're going to be walking 2 meters. And related work and other research uses gain levels up to 2x. After 2x is when a user starts to realize that a gain has been applied to the walking. And some studies even go for 3x, but there's a big problem, and is that if you use a very large gain, you start to suffer from VR sickness. And everyone knows VR sickness is an issue right now with VR. And unlike motion sickness, VR sickness can be 3 times more severe. And it's also measured with a similar sickness questionnaire, which basically asks the participants about how they feel about the symptoms from 0 to 4, and calculates a number and lets you know what's your level of sickness. So the big theory right now on why people are suffering from similar sickness or VR sickness is because there's a conflict in their senses. And a great example of this conflict is inspection. Whereas you're seeing on the virtual world that you're moving, your body's actually not moving, and this sensory conflict is what triggers VR. And in some people it's even worse when their body starts to adjust to what they're seeing, and it starts to cause accidents. So if we want to study large levels of TG, we might bump into this issue of VR sickness. So what we wanted to do with this study is basically see how difficult it will be for a person to adapt to large levels of TG. That's why we look at levels of 2, 4, 6, and 8. This is our work. So as I said, we want to see how they adapt and overcome to big levels of TG. And the way we measure this is we don't only measure the levels of VR sickness based on the questionnaire, but we also measure the changes on the center of mass and their gait parameters, such as the step distance or their cadence, and see how long they take to react to each level. So this is basically how our experiment works. We use only 6 levels, as I said, 1, 2, 4, 6, 8, and 10. We also recorded walking without a VR headset to see how it's the original gait parameters and the original position of the center of mass. We had 5 trials of each level of TG, and we applied TG on all axes, not just forward axis. We applied them increasingly, so they started without VR and started increasing all the way to 10x. And as you can see from figure A, you can see that's the space we used. They started walking at point A, walked to point B, and then came back to point A. And if you look to image B, with a beautiful opera house in the background that I was forced to do it because I'm working on Sydney, people started on point A and they walked towards the red arrow and then came back. I put all the arrows over there so you could visualize where each arrow was located based on the different levels of TG. And this is the timeline for our experiment. So they started with 5 trials of no VR. Then they moved it to 1, 2, 4, 6, 8, 10. And at the end of the experiment, we applied a full similar sickness questionnaire. For each level of TG, you can see on the image below. So we started with 1 trial. We applied a similar sickness questionnaire, then trial 2, 3, 4, and 5. So the way we measured this, first was the questionnaires. So we had 2 questionnaires, right? One between trials and one after the experiment. The one between trials, we tried to remove some symptoms from this experiment. We saw other research doing the same. The reason for this is we wanted to keep it simple for the user to answer. So we just asked some key symptoms during the experiment. We asked them not to remove the headset, so we don't want to break their immersion. And we used a scale of 1 to 10, so it was easier for them to compute a quick answer. And when they finished the experiment, we applied the post-experiment questionnaire, which was a more lengthy questionnaire about the whole symptoms, and it has the scale from 0 to 4. The other measurements we have were the behavior of the participants. So we calculated the center of mass. As I said, I first calculated the center of mass of the participants when they were walking without the VR headset. And then I calculated the center of mass when they're walking on their different levels of TG. And I made the difference of the position of the center of mass to see how much it differs when walking under TG and their normal walking. We also calculated the gait parameters, such as stepping distance. So if the stepping distance is shorter, it means the participant is struggling to maintain the center of mass in place. So that gave us a lot of information. And we also calculated the cadence, which is the number of steps per minute. And we also calculated the time it took them to complete a trial. So here are my results. The first I'm going to show you is the similar sickness questionnaire at the end of the experiment. The people in red are the people that, according to the questionnaire, they were motion sick. And the people in green are the ones that did not suffer any motion sickness during the experiment. I'm going to use this color scheme for the rest of the results, just so you know. You can see that from the red people, there's 3 people that had to quit the experiment early because they felt really motion sick, subject 2, 14, and 16. 2 of them quitted at level 6 of TG, and 1 quitted at level 8. And here are the results of the in-between trial questionnaire. So I just added up all the values they gave me to come up with this result. You can see in red is the people that got motion sick, green, no motion sickness, and black is just the average. If you see the people motion sick, the red, you can see how all the levels of TG are different to each other, and they start to increase as the experiment goes further. But if you see the people that are not motion sick, there's a statistical difference between 1 and the rest of the levels, well, 2, 4, 6, 8. But this is because the levels basically are really similar. Just after they experiment level 2, they don't experience any increase on their level of sickness. And here is how the results from the center of mass. Again, the bigger the difference in the center of mass means the more issues the participant is having on walking under this level of TG. If you see the results from the motion sickness group, you can see how from level 1 to level 2, there's a huge difference on center of mass, and it stays up. But if you look to the people that are not motion sick, you again see an increase between level 1 and level 2. But after that increase, after level 8, more or less, the difference actually starts to decrease. And we see similar pattern on the other results. If you look at the completion time, first of all, we compared how long it took them to complete a trial versus how long it took them to complete a trial without VR. That's the blue point mark on the graph. They were statistically different. For the motion sick group, there was no statistical difference, but you can still see how each trial takes them longer to complete compared to the no motion sickness group, whereas again, there's a huge difference between 1 and 2, but then after a certain period of stabilization, the time to complete a trial starts to decrease. And you see a similar trend also in stepping distance. So again, the blue is the stepping distance without VR, and compared to black, there's statistical difference. There's a huge decrease on the stepping distance once the participant wears a headset. But if you look at the stepping distance from the C group, you can see how it starts to decrease as the level of TG increase. So they're trying to adapt their stepping to the level of TG. Whereas people that are not motion sick, they decrease their stepping distance again on level 2, but they kind of start to maintain it over levels 2, 4, 6, and 8, and they actually decrease it on level 10. And this is their steps per minute. It's a very similar trend. You can see how people from motion sick group, they decrease their cadence a lot and then just try to maintain it low, whereas people that are not motion sick, they decrease their cadence, but over the time they start to increase it again. So it's kind of a pattern of adaptation. And so this is basically our takeaway message. We divided the people into 2 groups. For the no motion sickness group, you can see on all the measurements, there's a huge difference between level 1 and level 2. But once they reach level 2, they start to adapt over levels 4, 6, and 8, and you can actually see an improvement on the results. So we're basically hypothesizing that the people that are no motion sick, they adapted to the big levels of translational gain. So at the end, they were able to improve compared to the people that were not motion sick. So first of all, out of the 8 people that were in the group of motion sickness, only 5 people were able to finish the experiment. We had 3 people quitting, and they took longer to adapt. There's some adaptation on some of the participants, but that's at the very end of the experiment, and there's only the ones who were able to finish it. And this led us to a even bigger question that we probably will address later, which is like kind of a chicken and egg question. What came first? The people that were on motion sickness performed poorly because they were on their big issue of motion sickness, or their poor performances but led them to motion sickness. So some field work, as you might have guessed from the images I've been showing, I also recorded the brain signals from each of the participants. I use an encephalogram or an EEG device to see what are the brain signals during the recording. I hope this could give me more information of why is there such a big difference in the behavior of each of the participants. We're also looking at how an avatar of a person will affect how they walk or their performance, improve it or make it worse. So yeah, that's me. Thank you very much.
All right, thank you, Carlos. So next up, we have a recycling.